Okay, so I will be going over question 5. How many positive whole numbers are common divisors of any two positive whole numbers that have a greatest common divisor of 1860? So we are looking for how many positive whole numbers that are common divisors of any. So this is the key word here. They need to be common divisors of any two positive whole numbers that have a GCD of 1860. So what are two positive whole numbers that have a GCD of 1860? Let's say we have 1860 itself and like 2 times 1860. So their greatest common divisor will of course be 1860. And we are looking for how many numbers that are common divisors of both of these. So first of all, let's find the prime factorization for 1860. If you prime factorize this, this is 10 times 186. Of course, 10 is 2 times 5. And this is going to be 2 times 93. And 93 is 3 times 31. So that's how you prime factorize it. So let's have another example of two whole numbers that have a greatest common divisor of 1860. So again, these are two numbers that have a GCD of 1860, and we are looking for how many positive whole numbers that are common divisors of both of these numbers. And obviously, if you look at a few more examples, you'll find out that the question is simply asking you for the number of divisors of 1860, because if a number divides 1860, then it must divide, well, two numbers whose GCD is 1860, since that is the definition of a GCD. It's like the largest common number that can divide two numbers. So basically, the question is asking us how many divisors of 1860 there are that are positive whole numbers. And if you write the factorization out like this, we have 2 squared times 3 times 5 times 31. And now we have to calculate how many divisors there are of 1860. So for each of these numbers, some of you may know this already, but some of you might not, and that's okay. So the number of ways to find how many divisors there are of a number is by considering the prime factors. And for each exponent, you add 1 and you multiply it together. So for this one, it would be 3 times 2 times 2 times 2. And the reason why we do this is because, well, for each of the prime factors, you can either to choose to include it or exclude it from a factor we're building. So for instance, we can have like 2 to the first power times 3 to the 0th power times 5 to the first power times 31 to the 0th power. And that's going to give us 10. And that is a factor of 1860, or you can do like 2 here and like 1 here, and that's going to give us a different number. I think that's going to be 60, and so on. And by doing this, you generate all possible divisors of 1860, and that's just 24 if you multiply it out. So that should be the answer. Okay, thank you.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.